So kindly do that in the shortest time possible. Yes, Kibe.
I'm done.
Oh, you done?
Yeah.
Good. Abel, are you done? Alvin, I can see your responses. Very well. I think most of you are done with the exercise. It's not a tedious one. So let's go through and see what you've done. So the first one, do we have 0.4167?
Yes.
Yes.
0.4167 is correct. And the next one is 0.2114.
Yes.
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 0.2114 is okay. Then the third is 0.1180.
Yes.
Yes.
Yeah.
There is a problem if you write that as 0.118 because that is not what the mathematical table gives you. You always need to write to 4 significant figures. Then the fourth one, 0.1719.
Yes.
Okay?
Yes.
Yes.
Okay. Yes.
So what you needed to do first is to do the rounding off to 5.816. And then you read out the values from the table. And the mean differences column, you have to subtract 2 at the end. Then 1/3 is 0.3 recurring, so 0.3333. I believe that is what you got.
Yes.
Okay.
Yeah.
Anyone with a problem? Anyone with a problem?
No.
Especially whoever wanted us to go through this, it could be a challenge to him. Okay, then we can move to the next part, whereby we shall find reciprocals of numbers that are less than 1 and greater than 9.999. Good. What we said is that for these numbers, you need to first work out or write the numbers in standard form. And you did this in Form 1. About standard form, this is a concept that you learned in Form 1. So I believe you remember what you did at that point. Sorry, my power is out again, but we shall continue. Our first example is this one here, 27.28. You can agree with me that dividing 27.28 or dividing 1 by 27.28 using the long division method will really take you some good time. As we've said, the first thing could be to write this number in standard form. So how can we write that in standard form?
2.7 times 10 power 1.
2.728 times 10 power 1.
2.728 times 10 raised to power. Is easily stuck with the reciprocals. I would advise that you always split 1 over 2.728 times 10 raised to power 1 as 1 over 2.728 multiplied by 1 over 10. That could really help for someone who is stuck. It is the same thing if someone tells you, 1 divided by BC, 1 over BC can be written as 1 over B times 1 over C. It is the same thing that I'm doing on this one here. 1 over, assuming 2.728 is B and 10 raised to power 1 is C, just split them out. And then we now read from our mathematical tables the reciprocal of 2.728. 2.728. What is the reciprocal? 2.728.
0.3666.
3.6666.
Okay. And then what about 1 over 10? What is the implication of multiplication by 1 over 10?
3.666.
We add 1 decimal place.
We
add 1 decimal
One-
place.
We add 1 decimal
Rather, we move
place.
the decimal place to the right.
we move the decimal place to the right.
Yes.
One step to the right.
I
No, excuse me,
that
sir.
would be wrong. Remember,
When we
1 divided by 10 means when
0.1.
multiplying by 1/10, what does that imply?
Time is 0.1.
Times 0.1. Sindio?
10 raised to power -1.
10 raised to power -1. That is still okay. So in short, what you guys were saying is this. Multiplication by 1/10 is the same as division by
Can we say division by 10?
division
Yes.
by 10. That is
Yes.
correct. So that solves our problem again. So multiplication by 1/10 is the same as division by 10. Let me remind you something. When I tell you 5 divided by 10, you can also work it as 5 times 1/10. Sindio?
Yes.
That is the same thing we are doing here. So multiplication by 1/10, next we shall have division by 10. And division by 10 takes the decimal point how many places and to which direction? Division,
We'll check the decimal one place to the left.
that takes the decimal point 1 place to the left. Therefore, what is going to be our result for this one?
0.0366.
0.0366.
More than
You leave it.
No, this is not more than, and I was coming to that point. We only check for the 4 digits when you read out the reciprocal from the table. So where you need to ensure that you have 4 digits is on the value that you read from the mathematical table, which is 0.3666.
zero is not a
Whatever you
significant figure.
do with your tens and hundreds will not count. So where we check at is on reading the value from the mathematical table only. So once you come to division by 10, everything is worked out. You are sorted. You just give the answer as it's supposed to. Are we okay with that?
Yes.
So you only ensure that you have 4 significant figures at the point where you are reading the value from the mathematical table. The multiplications and division by 10 will not count at this point. So can we go to the next example?
Yes.
Okay. We have that value there. 38,585. The first step,
Standard
You write
form.
it in standard form.
writing that in standard form.
8. 5.
3.8585 times 10 power 4.
3.8585 times 10 raised to power 4. That is okay. And that is what we have on our screen.
1, 2, 3.
Now, next, remember, we are
2,
finding the
5,
reciprocal of
9.
38,585. So 1 over 38,585 equals to 1 over 3.8585 times 10 raised to power 4.
0.00002591.
Are we okay?
Yes.
Yeah, we've only replaced the 38,585 with its standard form. So we move to the next part, whereby we are supposed to do a rounding off because the digits exceed 4 that we can read out from our mathematical table. So we will have this as 3.859. And then we've also done the splitting as 1 over 3.859 times 1 over 10 raised to power 4. The splitting that I already explained earlier on. Then you now read out the value from the mathematical table. The reciprocal of 3.859
is 0.2591.
0.2591.
0.2591.
0.2591
2591.
Times 10 power negative 4.
I wish to explain something to someone because we want to remove all the confusion. Let me do a small writing on this. Are you able to see that?
Yes.
Yes.
It's the same concept that I'm applying here. If I can take you back to this screen. You can see that, right?
Yes.
So we've read out the reciprocal, which is 0.2591. And then what about this second part? 1 over 10 raised to power 4. How are we going to deal with it?
10 raised to power negative 4.
10 raised to power negative
4.
10 raised to power negative 4. But again, let me ask you something. What is 10 raised to power 4? What is the value of 10 raised to power 4?
10,000.
10,000. So in short, we shall divide 0.2591 by 10,000.
10,000.
Yeah. So division by 10,000, what is the result?
0.0002591.
Very good. 0.00002591. Now let me ask you a question. In the previous example, someone hinted that these values are more than, if you look at the result, the values are more than 4. Did you?
Yes.
Assuming you brought the same argument here, could it hold water?
No.
It wouldn't. So you only check for the four significant figures at this point here, where you read out the value from the mathematical table. Are we okay with that?
Yes.
Yeah.
So we've dealt with numbers that are greater than 10. In the next two examples, we'll deal with numbers that are less than 10. And our first one is that one, 0.2739. 0.2739. In standard form,
2.739 times 10 power
2.739 times 10 raised to power
negative 1.
negative
Negative
1.
1.
To our usual way of doing it. 1 over 0.2739 can be rewritten as 1 over 2.739 times 10 raised to power negative 1. And then we move over to how we split it. That is how we shall split it. 1 over 2.739 times 1 over 10 raised to power negative 1. We are good?
Yes.
Yes. So the
Yes.
next thing is to read out the reciprocal of 2.739 from the mathematical table.
Which is 0.3651.
0.3651.
5-1.
0.3651. Okay. Now we have another challenging mark on the other side. How are we going to deal with this part?
10 power negative
It
1, the
becomes a
reciprocal
positive.
is 10 times
Power 1.
times
10
10
times
10 power 1.
times
10
10
power 1.
power 1.
It will be 10 power
1.
10 power 1. Now I need to give somebody a hint. And I'll put off this screen and say this. I want to have this on a piece of paper so that someone will get to know what I want to say here. I remember I taught you indices and I gave you laws of indices. You can remember this, you are good to go.
Yes.
Can you remember this?
Yes.
Yeah.
Yeah.
Yes.
Laws of indices are also applying here.
Kabisa.
Yeah. That then means that 1 over 10 raised to power negative 1 will be 10 raised to power
1.
10 raised to power 1, which is just 10. Multiplication by 10, where does it take the decimal point? And how many places?
One place to
the
One
right.
place to the
One place
Form-
to the right. Therefore,
Right.
what is our answer?
3.651.
3.651 is correct. Our last example for the digits or numbers greater than or less than 10 is 0.0143. 0.0143. Standard form.
1.43 times 10 power
1.43 times 10. 10 raised to
10 times 10 raised to power.
negative 2.
That is okay. So that is okay with standard form. 1.43 times 10 raised to power negative
2.
Oh, sorry. I think I thought of 0.0143. Let me do something. Let me do something so that it is in tandem with what we are doing. Sorry, I need to. Okay, we are back. So that is it, 0.0143. That is what I ought to have given you. Sorry for that. 0.0143. So it will be 1.43 times 10 raised to power negative 3. We are okay?
Yes.
Yeah. Sorry for that. Then just a rewriting of the 0.00143. You are now versed with that. Then we go ahead and split. We move ahead and split as 1 over 1.43 times 1 over 10 raised to power negative 3.
Then the reciprocal is 0.6993.
0.69993. That is okay. Now the reciprocal of 1 over 10 raised to power negative 3 using laws of indices.
Is 10 raised to power 3.
10 raised to power
3.
10 raised to power 3. 10 raised to power 3 is 1000, right?
Yes.
Yes.
So multiply 0.6993 by 1000.
699.
699.3.
699.3 is good.
Huh? Oh,
Yeah, that is
oh,
okay. Now, we have a small exercise. Use your table of reciprocals to work out the reciprocals of the following numbers. Zinaonekana vizuri?
Yes.
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 Okay. The questions there are 4 of them. 0.0458, 102.4, 0.002978, and 4,368.
4,368.
Yes.
So thank you.